I think it's actually becoming more and more important as we have situations where we're both trying to drive the input requirements down as low as possible, and try to reduce the cost of everything, and also make the data analysis manageable. And so when you start to generate very low input libraries and you over amplify them, there was just a paper that came out in the JBT, um, uh, showing that it's that combination of low input and more cycles that drives a huge amount of PCR duplication. And so that you might have to throw away 50% of the or more of the sequence data, or a third to half of the sequence data if you're running it too low with too many cycles. And so I think it's going to be increasingly important to control the number of cycles to the absolute minimum. That it's like your input is what your input is. If like you can only get a nanogram of DNA or RNA, that's what you have. You got to make a library. But to be able to drive the number of cycles down is something special, because normally when you have a big project, or you're using the recommendations of the library prep company, they're giving you the general recommendations to make sure that you have enough library to get onto the sequencer. But if you have 100 samples or 200 samples that you're pooling together, you don't need as much library for each one of those samples, and you don't need to generate too much library from each sample. You can pool much less and still have enough total nucleic acid to get onto the sequencer. But that means you also need to be able to control how much PCR amplification that you're doing. The only good way to do that is with an instrument like the iconPCR.